massive warm welcome for massive math hackers, and today we will be primarily tackling lowest common multiple and HCF, as promised. Basically, this is just a continuation from where we left off, from our previous video of prime factorization. Now we will be embarking on highest common factor, also known as HCF, which will become clear shortly. Just stick with it for a while, until everything becomes clear as day. So to start with, suppose we prime factorize 12. This gives us 12 equals 2 times 2 times 3. From this prime factorization, we can deduce all the factors of 12, i.e. 2, 3, 4 and 6. We know that 4 is a factor of 12 because if you do 12 divided by 3, you'll get 4. Similarly, if you do 12 divided by 4, you get 3. Also, if you want to figure out that 6 is a factor of 12, just do 12 divided by 2, you'll get 6. In addition to that, you can also do 12 divided by 6, you'll get 2. Hence, 12 has factors 2, 3, 4 and 6, in addition to the obvious factors of 1 and 12. Similarly, we could prime factorize 18 to obtain 18 equals 2 times 3 times 3. From this we can list the factors of 18. 2 times 3 is 6, and also 3 times 3 is 9, are all factors of 18. Hence, the factors of 18 are, of course, the obvious ones, 1 and 18, in addition to 2, 3, 6 and 9. Some factors are common to both 12 and 18. These are 2, 3 and 6. These are common factors of 12 and 18. The highest common factor of 12 and 18 is 6. The highest common factor of 12 and 18 can be obtained directly from their prime factorization. We simply note all the primes common to both factorizations. 12 equals 2 times 2 times 3, and 18 equals 2 times 3 times 3. Common to both is 2 times 3. Thus, the highest common factor is 2 times 3, which is 6. Obviously, as you can see, 2 and 3 are common to both. But 2 is the least common factor and 3 is somewhere in the middle. But as the name suggests, we are after the highest common factor. Hence, 6 is the required HCF common to both 12 and 18. Given 2 or more numbers, the highest common factor, also known as HCF, is the largest, highest number that is a factor of all the given numbers. The highest common factor is also referred to as the greatest common divisor, also known as GCD. This is just a recap of what we learned so far. Let's say we're trying to find the HCF of 42 and 49. We know that 49 can be written as 7 times 7 and 42 is 7 times 6. All the factors are 7 and 6. The 7 is the only highest and common factor to both 49 and 42. Just more drills until you get the hang of it. Finding the HCF of 12 and 27. To start with, we prime factorize 12 and 27. As in, 12 equals 2 times 2 times 3, and 27 equals 3 times 3 times 3. Common to both is 3. 2, 4, 6 and 9 aren't common to both, but 3 is not only the highest common factor, but also the only common factor. Thus, 3 is the HCF of 12 and 27. This means that 3 is the highest number that divides both 12 and 27. Finding the HCF of 28 and 210. Simply follow the same procedure as prime factorization. To start with, the numbers are prime factorized. As in, 28 equals 2 times 2 times 7 and 210 equals 2 times 3 times 5 times 7. And just cross-reference what's the highest common factor to both. The factors that are common are identified, as in 2 and 7 are common to both. Hence, both numbers are divisible by 14. Since this number contains all the common factors, it is the highest common factor. Simple as, guys. Easy does it, right? Similarly, finding the HCF of 90 and 108, we start with prime factorizing, as in 90 equals 2 times 3 times 3 times 5, and 108 equals 2 times 2 times 3 times 3 times 3.
Please note, the factors that are common to both are color coordinated, as in 2 times 3 times 3, which is 18. Hence, this is the highest number that divides into both 90 and 108. Now we'll be embarking on lowest common multiple. Suppose we are given 2 or more numbers and wish to find numbers into which all the given numbers will divide. Here is an example. Given 4 and 6, we can see that they both divide exactly into 12, 24, 36, 48, 60, and so on and so forth.
Easy, as you can tell, if we were to multiply 4 times 6 equals 24, is one of the multiples, but not the lowest common multiple.
The smallest number into which they both divide is 12. We say 12 is the lowest common multiple of 4 and 6. As you can tell, if you were to divide 12 by 4, you'd get 3 exactly, and if you were to divide 12 by 6, you'd get 2 exactly. This is my point exactly.
Just to recap, the lowest common multiple of a set of numbers is the smallest, lowest number into which all the given numbers will divide exactly.
As just touched upon recently, 12 divided by 4 you get 3 exactly, and 12 divided by 6 you get 2 exactly.
Finding the lowest common multiple of 6 and 10. We are seeking the smallest number into which both 6 and 10 will divide exactly. There are many numbers into which 6 and 10 will divide. For example, 60, 120, 600, and so on and so forth. But we are seeking the smallest such number.
By inspection, the smallest such number is 30, as 30 can be divided exactly by 6 and 10. As 30 divided by 6 equals 5 exactly, similarly 30 divided by 6 equals 3 exactly. Thus, the LCM of 6 and 10 is 30.
A more systematic method of finding the LCM involves the use of the handy-dandy prime factorization. Let's say finding the LCM of 15 and 20. To start with, as a first step, the numbers are prime factorized, as in 15 equals 3 times 5 and 20 equals 2 times 2 times 5.
So here, the point to be noted is, since 15 must divide into the LCM, then the LCM must contain the factors of 15, that is, 3 times 5. Similarly, as 20 must divide into the LCM, then the LCM must also contain the factors of 20, that is, 2 times 2 times 5. The LCM is the smallest number that contains both sets of factors.
So far, we know the prime factors of 15 and 20 as clearly illustrated on the screen. Please note that the lowest common multiple will contain only 2s, 3s, and 5s as its prime factors. We now need to determine how many of these factors are needed.
The main question that needs to be addressed is, how many such factors are required? i.e., how many factors of 2, 3, and 5 are required?
The highest number of 2's occurs in the factorization of 20, hence the lowest common multiple requires 2 factors of 2.
Next, we consider the number of 3's required. The highest number of 3's occurs in the factorization of 15. Hence, the LCM requires 1 factor of 3. Consider the number of 5's required. The highest number of 5's is 1, and so the LCM requires 1 factor of 5.
Point to be noted, all the factors are listed in an orderly and non-repeatable fashion, i.e., only the highest number of factors are listed without repeating.
Therefore, the LCM is 2 times 2 times 3 times 5, which equals 60. Hence, 60 is the smallest number into which both 15 and 20 will divide exactly. Finding the LCM of 20, 24, and 25. To start with, the numbers are prime factorized, as in 20 equals 2 times 2 times 5, 24 equals 2 times 2 times 2 times 3, and 25 equals 5 times 5. By careful examination, we see that the only primes involved are 2, 3, and 5. The next step is to scan and identify where the highest number of 2s, 3s, and 5s occur. We can see that the highest number of 2s and 3s occurs in 24, so we list all the factors of 24 without repeating 2s from 20. Similarly, we just list 3. Next we consider 5, which occurs the most in 25, so we list it as is, without repeating 5 from 20.
Et voila, mes amis! The LCM is 2 times 2 times 2 times 3 times 5 times 5, which is 600. Hence, 600 is the smallest number into which 20, 24, and 25 will all divide exactly. And Bob's your uncle, guys, and if you prefer, Bobby is your auntie.
Ciao! A plus tard!
Au revoir, mes amis.
Adios amigos! Do svidania!
Crochet.
Auf Wiedersehen!
Sayonara. Zai Chen.
Namaste!
Peace out.